Hey everyone, great morning, great evening, or great afternoon, no matter what time you're joining me. And welcome to our AP Stats review, where we'll be going over unit by unit every important slide from the course in 30 minutes or less per unit so that you can be completely ready for our mini assessments on each unit and of course the AP exam. We start today with Unit 1A, where we're going to be talking about basic definitions and introductions to statistics all the way from the beginning of the year. And again, we're going to move fast. So feel free to pause the video or slow it down if you need a more in-depth review. As a reminder, you have the Google Drive with additional resources that you can use after you watch this video in order to assess your knowledge and make sure that everything that we cover right now makes complete sense for you before you're assessed on the content. So we start with the definition of statistics, which is the science and art of collecting, analyzing, and drawing conclusions from data, really the framework for the whole course. And I'll go back for one sec just so you can see. It's not letting me. But what you saw on the previous slide was just a data table. Okay, we're going to talk about how that's organized in a minute. So you've got individuals. These are the objects described by the set of data. And they can be people, animals, or things. You also have variables, and these are the attributes. So they take on different values for each of the individuals in the data set. I should say they can take on unique values for each of the individuals. Of course, multiple individuals can share the same value as well. We divide the variables into multiple different buckets, but the two biggest buckets are categorical and quantitative. And we practiced this a ton earlier in the year, but a categorical variable represents a label that you can assign a individual that places them into some category. So there's similarities grouped by some label. Quantitative variables are typically numeric. They represent either counts or measurements, and along those lines we'll be able to further divide them in a minute. And so here's just a list, and you're welcome to pause the video, but make sure that you can identify which of these are categorical and which of these are quantitative. Now, the one that a lot of people get incorrect on the prior slide are zip codes. And I don't think it was on there, but area codes as well tend to trip people up, that they look numeric, right? They're made up of just numbers. And so you are enticed to want to say that they're quantitative variables, but they're actually just a label. There is no numeric meaning to zip codes. It's not like somebody with a higher zip code than somebody else lives further north or makes more money. You remember the trick is, if you can't do basic arithmetic, if it wouldn't make sense to take the average of some zip codes or to add up some zip codes or to find the minimum zip code among a data set, then it's probably not quantitative, it's categorical. By the way, 33180 is just the zip code for Aventura. Great. So then we talked about a distribution, and if you remember back from the first day of this class, we talked a lot about bagels. And we said the distribution of a variable tells us what values the variable takes on and how often it takes those values. And the way to see a distribution is from a table. So again, this is the original data table. We're going to focus in on the rightmost column. It says preferred communication. So it's the preferred communication method of the individuals described by the data. And if you look closely, we can infer that the individuals described by the data here are humans, okay, human beings from Canada. So these are all provinces from Canada. And each of them can have a preferred communication method. It looks like we've got in-person, Facebook, cell phone, and text messaging. So in order to look at the distribution, you can make either a frequency or a relative frequency table. So the frequency table on the left gives you all of the individual data values, right? So cell phone, Facebook, in-person, text messaging. These are the values that can be taken on by the categorical variable preferred method. And then you have the frequency, which is just another word for count. So 2 people said cell phone was their preferred method, 1 person said Facebook, 3 said in person, 4 said text messaging. Now, in order to convert this into a relative frequency table, it's very, very easy. All you have to do is divide those frequencies by the number of individuals described by the data set. In this case, we had 10 individuals, and so you're going to divide 2 by 10 to get 0.2 or 20%. And notice you can express relative frequencies as either a proportion, so that's a value between 0 and 1, typically with a decimal in it, or as a percentage, okay? And so 0.2 and 20% are equivalent forms of 2 out of 10. We also unlocked some graphical methods that we could use to describe and display categorical data, namely the bar graph and the pie chart when we're talking about one variable categorical data. So on the left is the bar graph. You can see that the height corresponds to the relative frequency. In this case, you could also do it with frequency, the bar graph. And it's just important not to confuse bar graphs with histograms. So bar graphs are for categorical data, histograms are with quantitative data, and one easy way to tell the difference between them is that bar graphs have space in between the bars, and the labels for each of the bars go right under the bars, as opposed to histograms, who have no space between consecutive bars, and the labels go between the bars, not underneath them. On the right, you see the pie chart. So this is a circle. The full circle corresponds to 100%, and when we look at a pie chart, it's customary to talk in terms of relative frequencies, fractions, percentages, or proportions. Now, it's important on the AP exam as well as in life to understand that graphs are an efficient way of communicating a lot of information, but you have to make sure that those graphs aren't trying to mislead you. When you make a graph, you have to make sure not to fall for certain pitfalls, and when you're reading or interpreting a graph, you have to make sure that the reader isn't trying to trick you. And so there's a couple ways to spot a misleading graph, a couple things that you should look for. So first, make sure that neither of the axes are either too big or too small. Make sure that they're not skipping numbers and that the y-axis is starting at 0 where it would need to. That's for anything one variable quantitative. Axes should be labeled, data should not be left out, and a telltale sign is the pictograph, where they use pictures to represent bars in a bar graph. Remember, this tends to exaggerate the relative differences between the bars and is not appropriate for the AP exam. If you see a pictograph like the one here on the screen, you should reject this graph as an ineffective graphical technique, one that we do not approve of in the AP Stats community. So a little bit about bar graphs. You're going to represent each category as a bar in a bar graph where the height of the bars shows the category frequencies or the relative frequencies, and it's important to stay consistent. So if you're going to go with a relative frequency, you should do that for all of the bars. If you're going to go with just a frequency, you should do that for all the bars. Now notice there's a title. Each of the axes are labeled, and on the y-axis it's important that the spacing between the tick marks is consistent, and that you start at 0 on the y-axis. On the x-axis, again, it's important that all the bars are the exact same width, that you leave the same amount of space between all of the bars, and that's it. That's how you make a bar graph. And now onto the pie chart. So a pie chart shows each category as a slice of a pie. You can think apple or pizza pie, whichever you like more. And the areas of these slices are proportional to the frequency or the relative frequency for whichever category it is that you're discussing. Now, it's uncommon that you'll have to draw the circle yourself if you're asked to make a pie chart on the AP exam. They tend to give you the circle and even give you equally spaced tick marks around it so that it's easy to figure out how big to make each category. But what you have to remember is that 100% of the circle represents all 360 degrees of the circle. So if you wanted to figure out how many degrees, could ask you this on a multiple choice question easily, how many degrees you'd have to shade in for 20% of the circle, you can just set up a pretty simple proportion. So let me see if I can show you that on my screen really quickly. But essentially you would say 100% is to 360 degrees, as 20% is to x, okay? And then again, you just get 100% x equals 20% times 360 degrees, right? And so x, because 100% x is the same as saying 1 times x, which is x, is equal to 0.2 times 360. So 0.2 times 360, I want to say, is 72 degrees. And so you would shade in 72 degrees of the circle to represent sci-fi, and in this case comedy as well, because they're equal to one another. So that pretty much concludes our section on one variable categorical data, but oftentimes, and you've seen this throughout the course, we're interested in the relationship between multiple variables, and so we're going to start to talk about what methods have we unlocked in the course to describe, to analyze, to study two variables of categorical variables specifically, okay? And so first, just like with one variable data, you look at one column in a data table, you are going to turn two columns of a data table into what we call a two-way table, which is a method for summarizing the relationship between two categorical variables, okay? And so you can see you take the original data here where you have a respondent number for each of the respondents of some survey. You've got whether they're members of an environmental club or not, and whether they use a snowmobile or not. And essentially you are putting in the two-way table the joint frequencies or the joint relative frequencies. In this case, these are joint frequencies. So we have 445 people who have never used a snowmobile, okay, and are not members of an environmental club. We have 212 people who have never used a snowmobile, but are members of an environmental club. And it is customary to include row and column totals. So one row that does the total this way, and one column that does the total this way. And that's because it's going to make your calculations in a minute much, much, much easier. Now, from a graphical perspective, we've got three main ways that we can show two categorical variables. So we start with the most simple, the side-by-side bar graph, where essentially you're looking at the distribution of one categorical variable for each value of another categorical variable, right? So we're looking at all the people who are not members of an environmental club. Here you can see, oh, and you're not seeing my pointer, hopefully you are now, but for each of the people who are not members of an environmental club, you can see the distribution of their snowmobile use. Okay, so never, rent, and own. And again, if you added up these percentages on the left, you'd see that it adds up to 100% of the people who are not members of the environmental club. Side by side, and this is where the name comes from, you have the distribution of snowmobile use for people who are members of an environmental club. And you can see by comparing them that it's very clear that people who are members of an environmental club are much more likely to never use a snowmobile than people who are not members of an environmental club. We then have the segmented or the stacked bar graph, which is a very, very, very similar view to the side-by-side bar graph, where, again, the heights of the individual components are exactly the same as they were on the prior slide, but instead of them being next to each other for one variable of the categorical variable, like the membership status in an environmental organization, they're now stacked up on top of each other so that you can very clearly see how they add up to 100%. And so again, you can see side by side again what the relationship between never renting and owning a snowmobile is for people who are and are not members of an environmental organization. And again, it's really a personal preference which of these two graphs people like to use, but on the AP exam you can expect to see both. Finally, the graph type that I think is the hardest for people to get used to, but really is the most useful of the three, is the mosaic plot, because it communicates the same information that the side-by-side bar graph or that the stacked or segmented bar graphs can communicate. So again, we're looking at two variables of quantitative data, but this adds on one additional layer of information, which is, remember, the width. The width of each of the rectangles is proportional to the number of people in the original sample that correspond to that value for the categorical variable that's represented on the x-axis. So here we can see that there were many, many, many more people surveyed that were not members of environmental clubs than people that were. And again, if you actually measured, you could see how many more people were not members than were members. And just an AP exam tip, remember that when you're comparing groups of different sizes, you want to use relative frequencies, so these are percentages, proportions, even fractions, instead of frequencies. People tend to get these multiple choice questions wrong all the time because they look at a segmented bar graph and they ask them which of the following is supported by the chart, and they pick the answer that says more club members never use snowmobiles because that category looks bigger, looks taller, but you have to remember, they may have surveyed more people from the other categories. So again, we speak in terms of percentages or proportions, not in terms of numbers when we're comparing groups of different sizes. Back to our chart where we're breaking down variables into categorical and quantitative, we now learn that we can further break down quantitative variables into discrete and continuous. And again, a discrete variable is a quantitative variable that takes a fixed number of possibilities with gaps between them, and a continuous variable is a quantitative variable that can take any value in an interval on the number line, on some portion of the number line, we should say. Okay. Now, There's a trick in order to remember which is which. Discrete variables are things that can be counted, and continuous variables are things that can be measured. So we'll come back at the end and show you a list and make sure that you can differentiate between the two. Now, there are many, many graphical techniques that we learned in the class in order to graph quantitative data. Of course, the majority of the analysis statisticians do in the real world is quantitative, not categorical. And so you're going to see over the next several slides several techniques that you can use. The first being the dot plot, where each observation is represented by a dot above its location on the number line. And of course, higher columns represent values on the x-axis that are more common in the data set. And it's important to make all the dots the same size and the spacing between them to be consistent so that you can compare easily. We also have stem plots, which again, fairly similar to a dot plot, but again, each of the values is not a dot this time, but actually a number. We call that the leaf, and we'll show you that on the next slide here. So in order to take this data set of 20 values and convert them into a stem plot, we follow the following steps. So first you plot your stems. Again, the stem represents all the digits to the left of the final digit that you're going to be representing for your data set. In this case, the smallest value seems to be 13, if I'm looking correctly. The biggest value seems to be 57. And so your stems are going to go from 1, so that you can represent the 13, all the way to 5, so you can represent the 57. And it's important not to skip any stems, okay? Not to skip any stems. In this case, all the stems were used, but imagine you didn't have that value at 49. You'd still want the 4 stems so that you can clearly see the shape of the distribution, including gaps. The next step, once you've added your stems, is to add your leaves, and you can add them in the order that they appear in the data set. Some people like to skip this step and just order them directly, but if you do that, just make sure you go back and reorder them. The stems should be in numerical order, the leaves should be in numerical order, going from the smallest value closest to the stem, the biggest value furthest from the stem. And it is super important, in addition to a title, to have a key so that you can understand the scale of these values. Remember, the way that you would represent 4.9 could also just be 4 as the stem and 9 as the leaf. So the only thing that tells you the scale is that key. So you will be taking points off on the AP exam if you forget the key, so just make sure that you remind yourself not to. There are different techniques that we can use in order to get better views of the data when looking at stem plots. So one of them is to make a back-to-back stem plot. Okay, so that's where you're looking at a categorical split for some quantitative data. So in this case, we're looking at the number of pairs of shoes owned. That's quantitative. We know that that's discrete quantitative. But now we want to look at it by some categorical variable like gender. And so a back-to-back stem plot makes that possible. You have on one side of the stem the values for one variable of the categorical, one value of the categorical variable, in this case females, and on the other side of the stem, the values for the other value of the categorical variable, in this case males. And notice that on both sides of the stem, the numbers are increasing the further out you go from the stem. So on the left side, it's a little bit tricky because it goes from bigger to smaller if you're reading from left to right. But you have to remember, we're not necessarily reading from left to right. We're reading from closest to the stem to furthest from the stem. And the other technique that you're seeing here is splitting stems. So this is if you want a more granular view of the data. One way to sort of stretch out a stem plot is to split stems. So you have each of the stems listed twice, where the top one is the lower values 0 through 4 of the leaves, and the bottom value of the same stem is the upper or the higher values, so 5 through 9. So notice that the person that has 4 pairs of shoes goes on the higher stem. The people that have 5 already go down to the lower value of that same stem. Then we have a histogram. And a histogram is super useful if you want to really a bird's eye view, a summary view of what your data looks like. So you create bins, and essentially you're just putting in a frequency or a relative frequency for each of the bins. So again, this is less granular than a dot plot or a stem plot. So again, in this bird's eye view, the reason that it's so zoomed out is because we're actually choosing pretty big bins to fit our data into so that we can see how many values are within that similar range to one another instead of the particular values themselves. We always start with the raw data table. So what you can see on the left is for each of the 50 US states, the percentage of the residents in that state that are born outside of that state, the percentage of people that currently live there that were not born there. And we can see that some states have very, very low percentages like Mississippi with 1.8%, other states very, very high, like California with 27.2%. And so one of the early on decisions that we need to make is how many bins are we going to have? And the good rule of thumb to use in AP Stats is never less than 5, never more than 20. And we can take the number of observations, in this case there's 50 states, and take the square root of that number. That'll give us a good estimate for an appropriate number of bins. So in this case, the square root of 50 is a little bit higher than 7. So we want about 7 bins. And it looks like to represent our minimum of, I see a minimum right around 1.3%. I see a maximum of 27.2%. More or less we want to be able to go all the way from 0 to 30%. That'll represent all of our data well. And if we divide that distance, so 30, by 7, we're not going to get a really round number for our bin width. And so maybe we just divide by 6 bins instead of 7 bins so that each bin can represent 5%. And just remember that your upper bound of one bin is the lower bound of the next. But if you have any values at that specific value, like if we had any states at exactly 5%, that would not be in the first bar, which would go from 0 up to but not including 5. The second bin would actually start at 5 and go up to but not include the 10. And I'll just take this opportunity once again to remind you not to confuse bar graphs and histograms. Again, histograms, the ones we were just looking at, are for quantitative data, and in general, the bins are going to be touching. There's not going to be a gap between consecutive bars. So once we've already looked at the different graphical displays for quantitative data, we can talk about how to describe a distribution of quantitative data. This is a huge focus of FRQs in Unit 1. Almost every year you get a Unit 1 FRQ where it asks you to describe a distribution. And there's a couple different components. If you remember SOX, which we'll talk about a lot in the next couple minutes, we start by looking at a distribution's shape. And again, which distributions have shapes? Only quantitative distributions. Categorical variables distributions are not described by their shape. Okay, so up on top we see roughly symmetric, then we have skewed to the right and skewed to the left. Again, the tail tells the tail, so the side that you mention is the side that has the longer tail, not where the majority of the data is. And another way that we can describe the shape of a distribution is by looking at its number of peaks or its modality. So unimodal for 1 peak, bimodal for 2 peaks, multimodal for more than 2 peaks. And again, if there's no real pronounced peak, it's just roughly the same height for all the values, we say that that's an approximately uniform shape or uniform distribution. We could also describe a distribution by giving a measure of center, like median or mean, and this is the single value that I would give to describe a distribution to somebody who couldn't see it if all I was allowed to do was give them one number. Now, a value that certainly wouldn't be a good way of describing a data set with just one value would be one or more outliers. So these are values that tend to lie away from the rest of the majority of the data. And just like outliers, another unusual feature that we can talk about when we talk about single variable distributions of quantitative data are gaps. So these are regions between values where there is data, where there is not data. And please notice what it says here on the slide is that on the left you see a gap because there's actually no data between, looks like about 4.2 and 5. But on the right, that is not a gap. That is just 2 distinct peaks or clusters. That's a bimodal distribution. There is no gap there because there is data in that bar. It might be lower than the rest of the bars, but there still is data there. Speaking about clusters, these are just concentrations of data that are usually separated by gaps, but could also be separated by just low concentrations of data. Finally, we talk about spread or variability, and again, at this point, you'd learn that the range is the most typical way to describe variability. Of course, later on in the course, we're going to learn better measures of variability or spread than the range. So again, We can summarize this whole process with SOX, which essentially says let's look for the overall pattern and then departures from that pattern. So the overall pattern is the shape, the center, the spread, and the departures from that pattern are the outliers or the unusual features. So outliers, gaps, clusters, etc. This is a typical FRQ that you can expect. Again, we're going to explore it a little bit more deeply in Unit 1B, where they give you some statement with some context and that describes a distribution of quantitative data that they'll give you with either a dot plot, a box plot, a stem plot, and they just ask you to describe the distribution. And again, you're going to want to make sure to follow SOX and hit all of those major points with context. So we always say, don't forget your SOX plus context. And a more advanced version of a SOX FRQ is a comparative SOX FRQ, where they show you multiple distributions and ask you to compare the two distributions. So you're going to want to go letter by letter with SOX and make a comparative statement about each of them. And again, we'll have the chance to practice. But in this case, it's clear that the biggest difference among them, I mean, they seem to have relatively similar shapes. Okay, they seem to have relative similar spreads, but the main difference is with their center. None of them, by the way, had any unusual features that I could tell. Here, the most striking difference would be the spread or the variability. Okay, they seem to be decreasing as you go from top to bottom. F has the most spread, D has the least. And of course, here the biggest difference is the shape. So you've got skewed left for I, skewed right for H, and approximately symmetric for G, all unimodal. So that's it for our first review video. I'm sure for most of you, very simple stuff. Most of it I'm sure you remembered. You've got a bunch of additional resources in case this did not click on the first time. Of course, you could slow it down, you could watch it again. But if you want something else, something more, you've got Khan Academy, you've got AP Classroom, there's videos, there's progress checks on there. And you've got the Google Drive with practice tests and quizzes and Statsmatics FRQs that you could do for Unit 1A. But just remember, for those last two resources, most of those questions are going to include content from 1B as well. So you might as well wait till you review 1B and go back to both of those. But I hope you enjoyed and that you're excited. We've got 8.5 more units to go. We got this.